Hello, everybody. We are very pleased to have you with us tonight. I'm going to share my screen to start the introduction. So we are at the after work on CCUS and mastering carbon offset strategies. After a short introduction, we will listen presentations from Florence Del Prajano, Isabelle Czernichowski-Lauriol, and Claude Gapillou, and we will plan to finish at 7:30 p.m. after the final panel discussion and the conclusions. For those of you who don't know the EAGE, the European Association of Geoscientists and Engineers, just a few words. It's a global non-for-profit association founded in 1951. There are about 20,000 members worldwide, and the head office is in Netherlands. And the EAGE is organized also with special interest communities and local chapters like the Local Chapter Paris. My name is Lucia Levato, and I am part of the board of the Local Chapter Paris. We started this adventure in September 2018, organizing events for the community of geoscientists in Paris. And soon, toward the end of June, we will have a General Assembly with a renewal of the board, and some of us will just leave some positions to do other activities. And for the active members of the EAGE local chapter in Paris, they can apply for a position in the board as long as the membership to the mother organization EAGE is up to date. And for those who don't want to be in the board, but are willing to support continuously the activities of the local chapter, they can ask to join as operational members, as Anna and Aurélie have done for the past 1 year and a half. And if you want to know more about our organization, how we are organized, this link gives a organizational map of our local chapter, and it's also available from our LinkedIn page. So just for your agendas, you can save the date for the next after work of the local chapter is on June 22nd, and it will be dedicated to geophysics for mining exploration, and it's the last event before the summer break. And now, given the topic we are going to discuss tonight, I just put forward also a conference organized by the EAGE, the mother organization. The GET 2021 is the second Geoscience and Engineering in Energy Transition Conference, which will be held in Strasbourg, November 23rd to 25th. And it will also be possible to attend online, remotely. There is still a few days left to submit your abstract, and you have all the information on the website get21.org. Many different topics will be covered during the conference, including CCUS. And some of the items covered in the CCUS session are listed here, like geographic mapping of CO2 storage resources, storage characterization and estimation, and assessment and mitigation of subsurface risks, lesson learned from past experiences, and so you will have all the information on the website. And incidentally, this conference is also sponsored by the Club CO2, which we will hear about shortly from Florence. So why we decided to do this after work on CCUS? Well, we believe that CCUS has an important role to play in the the energy transition. And the recent live session of the International Energy Agency on May 18th, presenting a report called Net Zero by 2050, a roadmap for the global energy system, provides some support to this idea. In fact, in the report and in the video, which available on the web, there is this image, this figure, which gives a possible pathway, and this pathway has been elaborated by the International Energy Agency, and with over 400 milestones. And in this slide, some of the milestones are listed, and I've just circled in red the ones which seems to me more pertinent to the carbon capture and storage. For instance, starting from this year, no new unabated coal plants approved for development. So unabated means without taking care of the CO2 emissions. And by 2030, a phase out of unabated coal in advanced economies. By 2035, we have 4 gigatons of CO2 captured. 2040, phase out of all unabated coal and oil power plants everywhere, not just in advanced economy. And by 2050, 7.6 gigatons of CO2 captured. And of course, well, the report is very detailed, and you can access it at the International Energy Agency website. So before introducing Florence, just a few ground rules. Participants are muted by joining this conference, and the video is off by default. We will provide a recording of this after work, possibly next week, on the EAGE YouTube channel. And after the presentations, we will have 2 rounds of questions, 3 rounds in total. So after Florence and Isabelle presentation, we will have 1 round of questions. After Claude presentation, another round of questions. And finally, the final question and answer and panel discussion. You can write down your questions into the chat to everybody. So yes, everybody knows, but just a quick reminder to activate the chat icon. Just move the mouse or pointer downwards on your video screen, and then you click on the icon and you start typing your message. So thank you all for attending, and thank you to our speakers, Florence, Isabelle, and Claude. And so we have the pleasure to introduce the first speaker, Florence Del Prajano. She's a CO2 capture and storage program supervisor at IFPEN Énergie Nouvelle, and she's also president of the club CO2. She has over 30 years of program supervision and project management experience in the topics like CO2 capture and storage, subsurface in new energy technology, geophysics, and reservoir modeling. She holds a PhD from the University of Paris-Saclay, former Paris-Sud, and she has been a physics researcher at the École Normale Supérieure Cachan in physics, with a degree in physics. And so Florence is going to present the role of CCUS and the French club CO2. And I give the screen to you, Florence. I stop the share, and the floor is yours.
Okay, thank you very much, Lucia. Thank you very much. So as you say, I am a program manager at IFPEN in charge of CCUS for quite a number of years. But I am here today in the name of the Club CO2, and I will, and I am very pleased to have this opportunity to share with you the role of CCUS in the fight against climate change. But first of all, let me tell you that Club CO2, in fact, is a French association that gathers more than 30 players. This means academics, but also industrial players that are working together for the deployment of CCUS. These 34 actors are strongly engaged, in fact, in CCUS. So within this association, we share our experience on CO2 capture and storage. We are also a focal point for the ministry to discuss about, to have some information about CCUS. And we also have a role for promoting, in fact, national but also international cooperation on the CCUS. So as you see on this screen, our members cover the whole shade of CCUS. This means that we have some industrials that are big emitters of CO2 and that want solution to reduce their emission. We are some players that propose some solution to capture CO2. We have also some players that can transport CO2, some players that can store CO2, and some players that can convert CO2 for example, in biofuels, in chemicals, and others. So I will not say a lot of things about the role of CCUS worldwide, because Lucia, you give this impressive figure, 15 gigaton of CO2 that has to be captured and stored by 2050. Just remember, it is 40 million tons of CO2 that are captured today. So as you see, there is a real big issue, change of scale. But I would like to focus, in the name of Club CO2, on the French situation. So, of course, due to the deep decarbonization of the energy in France, CO2 emissions in France may appear quite limited, so something like 450 million tons of CO2 per year. But this is not because these emissions are limited that it is easy to go to carbon neutrality by 2050. And this is why France has been playing a key role in the development of a global climate policy, as illustrated by the adoption of the Paris Agreement in 2015. So now we have a strategy, which is the National Low Carbon Strategy, which is in fact our roadmap in terms of climate change mitigation. And what is very important is that our roadmap suppose that we use CO2 carbon and CO2 capture and storage. So for France, because again of the strong, the deep decarbonization of our energy, we have 4 pillars, in fact, to reach carbon neutrality by 2050. The first one is the full decarbonization of the energy production. So we will use nuclear and also a lot of renewable energy. We will significantly reduce energy consumption in all the sectors, and we will also reduce all emission process, which means emissions that are not related to energy. And the fourth pillar is carbon sinks. This means that we will make use of natural carbon sinks and also technological carbon sinks. And this is where CCUS plays a role. So by 2050, 80 million tons of CO2 are considered as incompressible emissions. This means that this 80 million tons of CO2 cannot be reduced by other solutions than carbon sinks. So 65 million tons of CO2 will be stored in soil, in forest, etc. And 15 million tons of CO2 will be reduced by the use of CCUS. 5 million tons to reduce emissions from industry, which has some emissions that cannot be avoided by alternative processes. And 10 million tons will be removed from the atmosphere through CCS. This means that we will make use of bioenergy with the CCS. And how will we deploy CCUS in France? So on the right side of the screen, you see you see a map of France that has been published by ADEME, which is the National Agency for Ecological Transition. And this map has been published last summer. And as you can see on this map, ADEME has estimated a potential for CCUS in France at a level of 24 million tons of CO2 per year, which is higher than the 15 million tons of CO2 that are supposed to be supposed to be reduced by 2050 in the national low carbon strategy. And they focus the deployment of CCS on three major regions. The first one is the Hauts-de-France regions, which is a region near Dunkirk. And in these regions, we have a potential of 15 million tons of CO2 that can be that could be captured per year, and storage is considered to be in the North Sea. The Normandy region, which has a potential of 6 million tons of CO2 to be captured per year, with again a storage in the North Sea. There is a link between Dunkirk airborne and these regions. And the third region is a region of Nouvelle-Aquitaine, New Aquitaine. And the potential for CO2 capture is 3 million tons, and with storage in oil and gas, in depleted oil and gas reservoirs. So this is the view of the French Agency for Ecological Transition. And as you have understood, there is a strong link with the European cluster to transport and to store CO2. So in France, CCS is really a necessity. It has to be developed by 2030 to capture incompressible emissions that come from industrial processes, and also to enable to remove CO2 that is present in the atmosphere to compensate, for example, emissions that comes from agriculture or transport. Last but not least, a really strong advantage of France is that we have in France industry and research organizations that are on track to deploy CCUS as soon as possible, let's say by 2030. This means that we have some laboratories. We are more than 200 laboratories that are working on CCUS in France. We have quite a number of industrial players that can capture CO2, that can transport CO2, that can store CO2, that can use CO2 to produce materials, to produce biofuels, to produce chemicals. And all these skills are ready, and they can also be deployed, in particular in Europe, because there is a close link between CCS in France and in Europe, and also worldwide. So I will stop my presentation here, because Isabelle Czernichowski will give some details about the projects that we have in France, but you have on the right part of the slide a short presentation of some major projects that we have in France. So thank you very much for your attention.
Thank you, Florence. So I will share my screen again to present Isabelle, to introduce Isabelle. So Isabelle Czernichowski-Lauriol, she's a research and public policy chief officer at the BRGM, which is the French Geological Survey. She's president emeritus also of the CO2 GeoNet organization. She has over 35 years of experience in the use of subsurface for energy. And since 1993, she has played a leading role in BRGM Pioneers research program on CO2 for geological storage of CO2. And from 2010 to 2014, she's been program officer of the CCUS and subsurface use for energy at the ANR, National Research Agency. She holds a PhD from Institut National Polytechnique de Lorraine and a geology and engineering degree from the École Normale Supérieure de Géologie de Nancy. So Isabelle will present us an overview of major CCUS developments in France, and I stop the screen share. Isabelle, the floor is yours.
I will do it.
Okay, to share the screen, if you move your mouse toward the bottom of your screen. Okay, great. We can see, and if you can put in lecture mode.
Full screen?
Yeah.
Is it okay?
Yes, now.
Okay. Thank you for inviting me to speak at this event. So I will give you an overview of major CCUS development in France. I remind the figures just pointed out by Florence in the France's national low carbon strategy to achieve carbon neutrality. Carbon sink of 15 million tons of CO2 per year in 2050 is foreseen for CCS to balance the irreducible emissions from industrial facilities, but also to withdraw some CO2 from the atmosphere through bioenergy and CCS, what is called negative emissions. So this technological carbon sink is what I like to call the geological carbon sink, in opposition to the carbon sinks for forest and land. Here we are going to store the CO2 in geological formations. So I have recently published an article in the Journal of the French Academy of Sciences to explain what CCS is. What is the geological carbon sink? Because we hear too little about it. And it is an important solution to mitigate climate change for irreducible CO2 emissions. So now I will give you an overview. You have seen that Adam is presenting 3 regions where we could immediately do some CCS to reduce the emissions. There are also other regions where there are currently and also in the past studies and projects being carried out. So I want to give you the overall picture, and you will see that the projects address both the reduction of CO2 emission at industrial facilities, but also through energy and CCS, and CO2 utilization, of course, as well. So let's start with the north, with the Dunkirk and Hauts-de-France region, which is a territory that is emitting a lot of CO2, 19 million tons CO2 per year in 2017. They have signed here a carbon neutrality pact recently, so they are very interested locally to CCUS. And there is the 3D project. Claude will talk about it later. They are preparing to build, they are building a CO2 capture pilot, ArcelorMittal steel plant, and are performing studies for transporting the CO2 under the North, to store it under the North Sea. In Le Havre and the Normandy region, so in region 2, here we have also quite high industrial emissions. There were in the past, there was a CO2 capture pilot at the EDF coal power plant in Le Havre for a few months. It was very successful, but now the coal plant is closing. At nearby in Port Jérôme, Air Liquide has been capturing CO2 since 2015 at a hydrogen production unit by natural gas reforming. And there are also studies to create a CO2 hub in the area, Le Havre, Port Jérôme, Rouen, along the Seine River. There was a FP7 European project in the past, COCAT, and now there is a specific study funded by ADEME to further investigate this option. And the idea is also to store under the North Sea, maybe through a connection to Dunkirk before going to the North Sea. What also is really important is the center of the Paris Basin, around Paris, the area number 3. Here you have much less CO2 emissions from industries, but you have many more smaller plants, industrial plants. And this is at the core of the Paris Basin with deep geological formations, with a very good storage capacity in theory, as it was assessed up to now, 8 gigatons CO2 in saline aquifers and hydrocarbon reservoirs. There is currently the Horizon 2020 Strategy CCUS project, elaborating local scenarios for CCUS development in collaboration with stakeholders to try to find local solution before, if possible, before thinking of, for instance, transporting the CO2 under the North Sea. First, can we do something in the area with onshore storage? And there is a follow-up project that has just started, pilot strategy, which is going to characterize in detail a geographical area in this part of the basin to propose the construction of a CO2 storage pilot. What is also really interesting is that the region Centre-Val de Loire in the south of Paris, around Orléans, on the map where BRGM is, there are 2 ongoing studies funded by the region. One is studying a scenario of bioenergy and CCUS for negative emissions, and another one, a scenario for combining CO2 storage with geothermal energy. I have more detailed slide later. In the Far East region, there was, some of you may remind, that there was in the past CCS demonstration project submitted by ArcelorMittal to the NER 300 program in Europe for funding for a demonstration project at the steel plant. But finally, this project was withdrawn due to the decision to close the steel plant. But the project was substituted by another project to study options for the use of CO2 in order to form valuable products. In the Rhône Valley from Lyon to Fos, Marseille, industrial area and harbor, is also a highly emitting CO2 region. And you have to also to note, it is a place in France where you have natural CO2 feeds, which are natural analogs, which means that we should be able to find places also to store CO2 permanently. And the Rhône Valley is also one of the regions studied in the Horizon 2020 strategic CCUS project for local scenarios. And there is probably potential for onshore and also offshore storage in the Mediterranean, but this has not yet been assessed. Except in the Fos region, there was previously 10 years ago an initial study, and there was in the very south a theoretical capacity of 54 million tons CO2. What is also interesting to note is that there are very interesting CO2 utilization pilots currently ongoing to produce algae, methane, methanol, and biomethanol. And also the connection with hydrogen could be very promising because hydrogen is key in the region strategies. And so it's important to elaborate further the scenarios that can be done in the Rhône Valley. Finally, I will highlight the Aquitaine Basin in the southwest with the Nouvelle-Aquitaine region. Here we have quite small CO2 emissions, but we have a huge potential for storing CO2 onshore, particularly in deep hydrocarbon fields, depleted fields, including the lac depleted gas field. And there could be also possibilities to store in saline aquifers, both onshore or offshore, but this has not yet been assessed. And in any case, you know that Total has run a CCS integrated pilot at La Route 10 years ago already, and has successfully captured, transported, and stored 51 kilotons of CO2 at 4.5 kilometers deep. And currently, there is a new initiative, very new, very challenging and interesting, to prepare a kind of hub in the southwest to store industrial CO2 coming from France, but also Spain, northern Spain, to store it in depleted hydrocarbon fields like the lac gas field. A few words about the Horizon 2020 strategy CCUS project coordinated by BRGM to elaborate strategic plans in promising regions of Southern and Eastern Europe. So for France, it is a Paris Basin and Rhône Valley, but you see there are other very interesting studies being done in the other countries, highlighted in blue here. And I just want to highlight give some indication about the Paris Basin area, where the project has mapped on the left all the emitters of CO2. There are mainly waste incineration plants producing energy. But there are also some, for instance, cement plants, glass plants, refineries, and so on, power plant, steel, food and drink. And it's as I told you before, there are important onshore storage potential in depleted hydrocarbon fields that are in red on the map, but also in deep saline aquifers. And in this area, there are two geographical areas: the two squares in violet. They have been more studied in the past, more in detail through dynamic simulation of CO2 injection. So we have a bit more reliable estimation of the storage capacity. And what you can see is that there is room to store the CO2, at least to start one or a few projects. But of course, we have to further investigate and characterize the geology. There are also possibilities for using the CO2 in greenhouses. There is a project in the close to Orléans. I will mention it also just later. This is a CO2 Cell Project. It is bioenergy CCS with CO2 use. In Orléans, the objective is to study the feasibility of capturing the CO2 at a biomass energy plant, then use it in greenhouses. Greenhouses have more and more growing needs of CO2 to boost the plant growth. Currently, the CO2 they use comes from the combustion of natural gas, or they purchase the CO2, but it is at a high price. So the objective is to provide CO2 at a competitive cost, high purity CO2 at a competitive cost. And what cannot be used, because they are quite huge quantities, it will be stored permanently in the underground nearby. So studies are being conducted too. And the project is also going to investigate the possibility of reversible storage to match the demand also of the CO2 for the greenhouses. Now, a few words about the project combining geothermal energy and CO2 storage. This is a specific concept where the CO2 will be stored and injected entirely in a dissolved form in the geothermal doublet. So in the injection well, we're injecting cold water with the dissolved CO2. And in the production well, heat can be produced to feed a local network or to feed the industry. So this is well suited for small isolated emitters onshore. And there are quite many studies and projects being developed. And now we are aiming to prepare a pilot somewhere in France or in Europe. Now, one word about the very new Horizon 20 project that has just started this month, pilot strategy. It is a kind of follow-up of the strategy CCUS project. It was answering the call for CO2 geological project pilots. So here, the aim is to characterize very in detail the storage complex in the sense of the EC directive, and then prepare for 3 CO2 storage pilots in France, in the Paris Basin, in Portugal, Lusitanian Basin, and Spain, Ebro Basin, and also in the 2 other countries in blue, advance maturity and readiness of storage resources. All this will be done in consultation, close consultation with the local stakeholders and the regional stakeholders, using the regional stakeholder committees that were launched in the strategy CCUS project. France, as you see, is very committed in the European scene and also on the international scene. France is member of the EU set plan on CCUS, on accelerated research infrastructure, and at international level of IAGAG, CSLF, Mission Innovation, and the ISO Technical Committee on CCS. And my last slide is about this very important international event that will take place next week in Paris. It will be broadcasted from Paris, but will be online. You can access it online. Still time to register, and it's about how joining forces and accelerate to reach net zero carbon neutrality, and align both policies, funding mechanisms, investments, and also technologies, climate technologies, in order to achieve our goal to limit climate change to 1.5 degrees C. It will be, there will be a specific session dedicating to the funding of CCUS on the 3rd June at 11:30 Paris time. There will be also Climate Tech Awards. So it is still time to apply if you send a small video to present your startup. But you have to do it very soon. This is my last comment, and I am ready with Florence to answer questions.
So thank you very much, Isabelle, and thank you, Florence, again for your presentations. Yeah, we can start the questions. We have a few questions now. The first one from Rachel Moore. Has France considered direct air capture rather than or in conjunction with the BECCS, so bioenergy with carbon capture and storage? Also, given the relatively high number of BECCS, how will sustainability of biomass be addressed? And I don't know if
yes. In fact, in the national law strategy, the objective is to reach carbon neutrality by 2050. So it's clear that maybe by 2050, the deployment of DACs will be quite limited. So this is why for carbon removal, so to remove the CO2 from atmosphere, BECCS is a priority. Before 2050. It appears also in the International Energy Agency that priority at the beginning is put on BECCS, and DACS comes to a larger development after 2050. Regarding the availability of the biomass resource, it is really a challenge, and it is clear that this is something that we are investigating, and at IFPEN we have launched I think it is nearly 2 years ago, CHAIR, which is a big program of a PhD and postdoctoral positions to address all the issues regarding to the deployment of BECCS, let's say of solutions for negative emissions, and in particular direct air capture and bioenergy with CCS. And this is something there are some PhD theses currently ongoing to evaluate where it will be the most suitable to develop BECCS.
So thank you. Then from Mustafa Sebas, is there any, because this keeps moving, the chat, is there any regulations and obligations on companies to reduce the CO2 emissions and contribute to CCUS project?
So it's clear that there are some regulations which are, for example, in Europe, the ETS market, which gives some quota to quite a number of industry to reduce their CO2 emissions. So this is something that is ongoing, even if the regulation and the obligation to companies to reduce CO2 emissions are respecting to become stronger and stronger. But this is something that exists in quite a number of countries. Anyway, it exists in Europe, and it will be more constraining in the coming years. There is no really obligations to contribute to a CCUS project. CCUS is one of the solutions, one solutions among a portfolio of solutions to reduce CO2 emissions. So industrials are free to use the solutions that are the most suitable for their industry, in fact. But in France, there are some priorities that are made on that are put on a four way to reduce emissions, which are reduce the use of renewable energy efficiency, work on an alternative process to that do not emit any CO2, and then the use of carbon sinks and the use of CCUS.
Thank you, Florence. Now we have some questions for Isabelle from Claude Sadala. Are there regulations on purity of stored CO2? As we know, it may be captured with impurities.
Yes, so the regulation is given in the European Directive on the geological storage of CO2. So it is said that the CO2, the gas should be composed of overwhelmingly CO2. So the exact quantity is not fixed in the regulation, but it means that it is more than it's about 97% or more purity probably. But this is still a question that there is not. I cannot give you a value. It has been debated a lot in the past, but without any conclusion. And but it is almost pure CO2. And of course, the higher the purity, the most costly it is to capture the CO2 to a very high quality. So it will be also about the economic of the project, but also of course, the safety and security aspects are also very, very important.
Yeah, very important aspects. So from Rachel Moore, has France created a national CO2 storage atlas?
No, France has not done that. We have done some, in the past, some studies. There was, but it was quite a long time ago. There was also a GIS that was elaborated, but is no longer active because, you know, in Europe there was a first wave of CCS projects quite a decade or more ago. Now there is a renewed interest, so now we have to reactivate and revisit all the previous studies and now make additional studies to go more in detail. Now that we see there is an interest from policies, national policies, but also from the industrial companies that see the need for them to use CCS in addition to other means to reduce their emissions. Now we are seeing this need for having CCS deployed in France to help to decarbonize the industry sector. So I think it is time to start again and make in-depth studies to prepare France to deploy CCUS on its territory.
Okay, from Mustafa Seba is in the 6th region, I think, of your presentation, ARA. Is there any project for CO2 capture given the high industrial activities in the region? You mentioned H2 energy. Can you explain the synergy, please?
Yes. So in the Provence, in Lyon, in the Rhone Valley, in fact, in the Rhone Valley, yes, there are CO2 capture pilots. For instance, there is a demonstrator called Jupiter 1000 in the south of France. They are going to capture the CO2 and combine it with at an industrial plant and combine it with hydrogen produced by water electrolysis. So this is one way to create synergy between hydrogen and CO2, in fact, through the valorization of CO2 to create synthetic fuels, for instance. And another synergy could be there is the current process that is used for producing hydrogen in many parts of Europe or even in the world is through the steam methane reforming. I told you that close to Le Havre, Air Liquide is doing that already. And so there can be a possibility here to produce hydrogen from natural gas and store the CO2 in order to produce low carbon hydrogen. There are projects prepared in the north of Europe, and this might be interesting for France too. We don't know, but as I told you, it's really important to elaborate scenarios at the territory level, together with the stakeholders, and see what are the best options to reach carbon neutrality. Do we need or not CCS? Do we need to produce hydrogen? Do we need to produce it also from natural gas in case we cannot produce enough cost-efficient hydrogen through water electrolysis? All these questions are really important, and there are no yet answers. We all have to discuss that and elaborate the best scenarios, the more efficient and the more economic, and the more acceptable also by the society, the citizens.
Yeah, actually, the following question is from Rachel Moore, and how will the public be engaged to increase public acceptance for onshore storage in France?
We don't know yet. We can never know, but these aspects are, for instance, a key issue being tackled in the Horizon 2020 project I was mentioning. For instance, the strategy CCUS and the pilot strategy. In the project, there is a dedicated work package on societal aspects and societal readiness, and making the citizens not only aware about the project advancement, but also involved in the project, in the discussions, is, I think, the way to try to build a scenario that can make sense for the territories. And then if they make sense, because they see it useful, we believe there are no reason that it should not be done because it is done already in other countries. But if it is clear that if there is, if people don't see the need for that, if we can find other ways rather than CCS to reduce the CO2 emission, it will be great. If we don't need to deploy CCS, but we don't know yet exactly now how to convert the national low carbon strategy into practical actions. This is being prepared.
Yeah, it's a very important topic. I suggest that we have still a couple of questions, but since we have the question and answer, I suggest that we take them at the final panel discussion maybe, and we move with the Claude presentation, okay? If it's okay. I have the questions noted down, so we can start from those questions afterwards, because so we can. So I will share my screen again to introduce Claude. Claude Gapillou is a senior reservoir geologist at Total Exploration and Production with over 40 years of experience in mining and petroleum geology. His domains of expertise include oil and gas exploration and development, and reservoir synthesis, geological and geophysical, and modeling. And he's now working on the R&D projects of Total for CO2 geological storage. Claude holds a PhD in mining geology and metallurgy from the Sorbonne University, the former University Pierre and Marie Curie, and also experience in with different companies in the mining and oil sector. And so Claude is going to present us the D3 CO2 capture project at the ArcelorMittal steel plant in Dunkirk, and the perspective for transport and storage of CO2 under the North Sea. And I stop the screen sharing, and the floor is now yours.
Well, good afternoon. My presentation is divided in three chapters. Some generalities on the project, a first chapter about the CO2 capture, a second one focused on the storage of this CO2, and there will be one slide for conclusion. This integrated study gives a complete vision with several possible options, from the capture of the CO2 from the ArcelorMittal plant in Dunkirk, located in the north of France, northwest of Lille, to its geological storage in the North Sea. The Dunkirk ArcelorMittal plant, the only plant, has an annual production estimated to 12 million tons of CO2. The first step is the use of new amine technology developed by IFPEN, the DMX process. It is more efficient and less expensive in energy than the traditional one. The main interest of the amine is the direct segregation of it and the presence of CO2, so less energy is used for the treatment necessary to regenerate the amine and to use it clean again. The second step is to transport this CO2 in a regional deep geological reservoir. And the final objective is the creation of a cluster around Dunkirk within the possibility to store about 10 million tons of CO2 by 2035. This slide explains in more detail the previous one. IFPEN is the coordinator of the project, which includes 12 partners from 6 European countries, through 8 topics ranging from the capture process, the elaboration of the solvents, the treatment of gases, the transport and the storage of CO2, with also a topic that concerns the societal and economical aspects. It is a ARCH 2020 project for 15 million of euros. The capture of the CO2. In 1957, starts the first industrial amine treatment in France with the gas, with the development of the front field of Lac, which contains about 24% of acid gas. Since 60 years, many evolutions of the process have been developed with improved amides and new process as the SPECS, which is cryogenic separation. The DMX technique are the more recent stage for amine solvent evolution. The objective of this process is to improve the performance of the traditional amine-based process, which consume a significant amount of energy for solvent regeneration. Here, the capture of CO2 is based on a high cyclic capacity solvent that decants in two phases, with only the CO2 rich phase sent to regeneration. Energy savings in between 13 to 40% expected, with a direct impact on the capex with the save value. The efficiency of this solvent is high, with a chemical stability which permits to easier regeneration of the solvent. The solvent produced is at seabar pressure and is very pure. An IFPEN conducts conclusive test in its Soleil's laboratories. Now, this slide want to explain to a non-specialist the principle of a sour glass treatment process. A traditional unit is composed of two elements, an adsorber for glass cleaning and a stripper for solvent regeneration. The sour gas flow penetrates at the base of the adsorber and go up. The solvent is ejected in the absorber on top and go down, capturing the CO2 and create a rich solvent, which is produce a rich solvent and produce a clean gas. So the CO2 rich solvent is conducted to the stripper where high temperature water vapor clean it and permit to inverse the amine CO2 reaction with the liberation of the CO2. And obtain a regenerated solvent which go back to an absorber. With the DMX process, we add a decanter in the process and only the rich phase solvent reached to the stripper. As a conclusion for this chapter, the 3D pilot project aims to achieve a capture rate of 0.5 ton CO2 hour in 2022. If success, the next step post the 3D project will be to build the first industrial unit at 125 ton CO2 by hour, what represents more or less 1 million ton years in 2025. Last detail for this chapter, the CO2 is stored as a liquid phase. For the storage of this CO2, our objective is to store in 2025 10 million tons of CO2 by year. Now, where can we find the storage resources from Dunkirk? Below Dunkirk, there is no possibility of storage because we are in a geological hydrothermal point with the basement is not deep and there is no reservoir. There is no storage resources in recognized today in the channel and in the basin of Paris. We consider that the resources are limited and economic and societal acceptance are questionable. The solution could be the North Sea, where two active projects exist today. Snøhvit is the north of the Norway, largely outside of this map, about 2,000 kilometers north of Sleipner, which is in the south of Norway, and which is also the first worldwide industrial project since 1996, with more or less 20 million of tons stored today. In these two cases, Snøhvit and Sleipner, the storage is in deep water saline aquifer. Actually, we have the Northern Light project in progress, always in Norway and also in aquifer. Many projects exist in UK. The two main are Acorn in Scotland with resources in hydrocarbon or depleted reservoir. On net zero side in the South North Sea with essential of resources in a regional aquifer. Three projects exist in the Netherlands in demobilized depleted gas field, Athos, Porthos, and Aramis. And there is also some projects on paper in Denmark in aquifer or oil gas field. In southern North Sea, numerous capacities incoming at the next years due to the end of life of hundreds of reservoirs. The first concept retained for the storage possibility for the CO2 on Dunkirk is a standalone case, a storage in a UK offshore depleted oil field. The second one is to use the capacities of the resources of the Northern Light project. And the third one is a Dutch case, the depleted field. Well, for the CO2 storage, North Sea is a big hub with numerous possibilities. And it is required to match the CO2 point sources to CO2 sinks. It is critical to commercial CCS. It is a critical point to commercial CCS development at a large scale. Scale efficiency is the main key. For the standalone case in UK, there are numerous projects in CO2 storage next year, and because all the south of the North Sea is in the reach of gas field, which we produce for about 40 years. And all these fields are the production are today, all these fields are depleted, and will stop definitively in the next 20 to 25 years. So numerous resources for CO2 storage will be available in this field and also in the aquifers around this field. Geologically, the area is well known with abundant set of data and a lot of studies. The actual main project in this area is a net zero Teesside one. It is a good example with a double set of storage with a large aquifer between in the north, aquifer named Endurance, and eventually second possibility in Hayward field, more in the south. In the case of net zero Teesside, the CO2 issued from different plants onshore will be transported by pipe in this aquifer, which is regionally well known for the Endurance case. The interest to store CO2 in an aquifer is that very often we have large extension. The aquifer have good initial pressure and temperature conditions with no low depletion only in the case of existence of hydrocarbon field associated with it. In an aquifer, there are limited legacy wells, which could sometimes present risk for leaks. The interest to store CO2 in depleted hydrocarbon field is that the reservoirs are well known in terms of quality or dynamic condition, but the main question is the question of pressure. If you inject a liquid CO2 in a low pressure reservoir, you can find an effusion effect with deposit of ice or plugging of the wells of the reservoir with more salt and carbonates deposit. In the case of a depleted reservoir, installation as platform, pipeline, or wells can be reused if they accept CO2 transit. But the number of the quality of the cementation of legacy wells, which are always potential leaks and have to be regarded. And also the resources are generally lower than in aquifer. Some words of the Northern Light project. The Northern Light project is today the most advanced one for the CO2 storage, excepted Snowy and Sleipner. The objective is to store CO2 issued from the Oslo area to a deep North Sea reservoir in a large regional aquifer between the and deeper the Troll field and the Osberg one. The CO2 is transported with dedicated boats along 850 kilometers to the terminal of Colfix, of the plant, the boat, the terminal of Colfix, and after it is injected with a 100 kilometer pipe to the aquifer, at the 260,000 meters deep. The Netherlands, we are in continuity of the UK South gas basin. There are also numerous potential resources in the next year because all the gas fields are the end of life. So there are today three main projects. Portos, three main projects which correspond to the three rivers of pipeline in the Netherlands. The Portos for the fields in front of the port of Rotterdam, Athos for all the fields in front of the port of Amsterdam, and Aramis for all the fields in the north of the Netherlands. Donc, today, these three projects are already on paper. Well, there are many studies on it. Aramis is the more advanced today. Bon, in conclusion of my presentation, the 3D DMX demonstration Dunkirk is a complete project from the capture of the CO2 to the storage. The project to demonstrate technically the reality of the DMX industrial pilot process, to prepare on paper for the establishment of a possible first industrial unit at the ArcelorMittal site in Dunkirk, and to prepare for a possible CO2 storage in the North Sea reservoir with objective to define the contours of the future European hub linked to around the area of Dunkirk. Thank you for your attention.
Thank you, Claude. So we have a question, but I don't know, it's not really related to the presentation, I guess. It's from Guys van den Doel. Yesterday, in the landmark case, a Dutch cut other shells to cut its carbon emissions faster. Expected is the more pressure will placed on high emitters. How are CCUS and carbon offset strategies affected by increasing pressure to reduce at the source? So I guess this is more a question of maybe which can be taken at the panel discussion. We have a question from Charles Leslie. Why do we not use CCS at the coal power station? We can do this today if we want. And from Tariq Maltar, for Claude, can you please elaborate on the compatibility of CO2 injection in with different water salinities?
With the salinity in water? Yes? Hello? Hello, hello?
Yes, yes. Hi, Claude. Yes, salinities in water, different salinities in water.
More the water is saline, less you can solubilize CO2.
So you mean the less salinity, the better?
Less the salinity, for lower the salinity, it is not the reservoir with low salinity are not also good reservoir for storage because they can be used by human activity.
So
but more the salinity is high, less you can dissolve the CO2. Bon, après, it is an equilibrium between the salinity, the volume of the aquifer.
So Claude, you mean that it's because different precipitation of different elements and components with high salinity. So the less the salinity, the less the precipitation that takes place. Is this the case?
Now, the problem of precipitation, well, it depends if you inject CO2 in supercritical phase as a liquid, or if you inject gaseous. If the problem is if you inject gaseous CO2 in a depleted reservoir, you have no main problem. If you inject for salt for deposits, if you inject supercritical CO2 in aquifer with high pressure, good temperature, we have no main problem. The main problem is when you inject liquid CO2 in a depleted reservoir. It is the big problem today. It is a better case to have salt deposits and also asphaltate deposits, salt, all deposits that plug the reservoir.
Okay. I take the last question for Claude and Jean-Charles. I think your question can be put in the panel discussion, which will follow this question to Claude. Regarding storage in depleted hydrocarbon reservoirs, do you expect the need to re-drill dedicated CO2 injector wells, especially if the metallurgy of existing wells is not suitable due to possible corrosion?
It depends. It depends on the quality of the well, the quality of the steel, the quality of the cement. For example, for the pilot of LAC, we inject directly in the wells, in the older wells, because the gas of the reservoir was a sour gas, so there was no problem to inject the CO2 in it. In some wells on the North Sea, on wells that are total regard today, it is not the good steel. It is better to do with the new wells.
Okay, thank you, Claude.
After you have the problem of the cementation, when you have an older well which is 20, 30, 40 years old, it is not sure that you can inject directly. Produce a well or injecting, it is not exactly the same thing in terms of constraint inside the well, and after in terms of temperature in the well, pressure in the well. So.
Okay, so thank you very much, Claude. Maybe we can move to for the last 10 minutes. There are several questions still in the chat which can be addressed to the panel discussion. Maybe if you can please stop sharing your screen. I just want to introduce on top of your screen, you should have stop sharing to stop sharing the screen. Okay, thanks. Thank you very much. And so now we can move to the final part of our after work today, which is oops, sorry. Yeah, can you see my screen? Is this final question and answer session where we have the three speakers, thank again, and Jean-Charles Ferran, who helped me to co-organize this event, will maybe join and give final words of conclusion. And so I suggest that you can keep asking questions in the chat for this final part, but maybe I resume the questions which were for Isabelle. So there were a couple of questions for Isabelle from Angelica Wolf. Are the CCS projects accompanied by monitoring plans? I think this is a good question for everybody, actually. So Isabelle, if you want to take the question.
My microphone was not on.
Okay. Yes, now it's okay.
Yeah, yes. Monitoring is extremely important and is required. So there are many research projects developing innovative monitoring methods, and also concrete projects, for instance, for preparing pilots, etc., are also incorporating monitoring activities, and including the baseline monitoring, to monitor many parameters before any activity is done on the site, in order to be later able to discriminate whether, if there is a change, for instance, in the subsurface or at surface or in the vegetation, if this could be linked to the project or it is another cause, natural or anthropic cause, but not linked to the project. And this is extremely important. We see that, for instance, for geothermal projects, it is also a key issue. So indeed, monitoring is extremely important.
Okay, so I think we had a question again about water salinity preference for CO2 injection. I think Claude has covered this part. And from Quentin Mumbach to Isabelle, has there been a feasibility study on storing CO2 in shallow depleted oil and gas reservoirs?
So I don't know what you mean by shallow. We can store CO2. The objective is to store it in a supercritical form. That means at depths greater than 800 meters. Because in this case, it will be in the dense phase, it will occupy much less space, so you can store more CO2. So I know that in France, there was an inventory already carried out on depleted hydrocarbon fields. I don't know if there are shallow fields, shallow reservoir, shallower than 800 meters. I don't know, but if that is the case, they are not considered suitable for permanent storage. Because the volume, their storage capacity would be much less, unless it might be of interest for a specific other reason.
Okay, thank you. So maybe I can take again the question from Guys van den Doel, and then to anybody in the panel who would like to answer. Yesterday in the landmark case, a Dutch court orders Shell to cut its carbon emissions faster. Expected is the that more pressure will be placed on high emitters? How are CCUS and carbon offset strategies affected by increasing pressure to reduce all this at the source? So I don't know if Florence or wants to take these, or Isabelle.
It's clear that CCUS is a solution that can be deployed now, and it is a solution that, since it is some technologies like post-combustion, the one that is currently under demonstration on Dunkirk, this is a technology that can be applied to quite a number of emissions. This means that if we put some pressure on emitters, whether they are high emitters or low emitters, and if the pressure is put now, they will have to apply some solutions that are existing today. And CCUS is a solution that can be applied today. I would like to add that if we wait, reducing CO2 emission in the atmosphere, the more we are waiting, the more difficult it will be difficult to abate solutions. And then this means that you will have to use solutions that are efficient now. So let's say that I will say that if you want to cut your emission faster, then you have to make use of CCUS more than if you plan to cut your emission later on.
Thank you, Florence. Maybe Jean-Charles, you can ask directly your question now. You are in the panel. You have your question about the advantages of the methodologies used to capture CO2. Jean-Charles, can.
Yes. Good evening. Good evening, everybody. And I apologize again that just to be attended during the talk of Isabelle. I couldn't attend before. Yeah, I would like to rebound now on what just Florence said, and I will have a question regarding the technologies. I like the scenario of Florence. I mean, if we need to speed up everything now, tomorrow, so Florence, you tell us that we are ready.
In quite a number of sectors, yeah. Oh,
okay.
Yeah.
So because I remember I've seen some scenario from BP 6 months ago showing a very, for example, a very, very slow rate of the CO2 price. So over 20 years. So now imagine this scenario where the pressure, and I believe this scenario can occur. I mean, because of the pressure of the climate change. If this scenario happens, you say that we are ready. So my question is about the technologies. I mean, do you see some area of?
Congratulations.
Yeah. Do you see some area of technologies that needs really to be industrialized at that stage to make all the CCUS industrial now?
Okay. So I will come back on what I said when I said we are ready. This means that today we have some solutions. We have some technologies that can help quite a number of industry to reduce their emissions. Some technologies, and in particular some capture technology. This does not mean that we can reduce immediately all the CO2 emissions, because we have some technologies that are ready, but there are some challenges in the speed up of the deployment of CCUS. All the scenarios show that it is very important for CCUS. If we want, it is very important if we want to reach carbon neutrality by 2050. It is very important that CCUS can be deployed at an industrial scale, which is not the case today, by 2030. Okay, so again, a few figures. Today, we are capturing and storing 40 million tons of CO2 per year. By 2050, by according to the scenario of International Energy Agency, we need to go from 40 million tons to 7.5 gigatons. So you see there is a big step. By 2030, the level is, let's say, something like 800 million tons of CO2 that have to be captured per year. So this means that we have some technologies that are ready. So we are ready for quite a number of technologies now. But if we want to achieve the objectives of the carbon neutrality of a 5.7 gigaton of CO2, we need to increase the performance of the technology to reduce the cost. The cost of CO2 is in Europe, according to the ETS market, it is currently 50 euro per ton of CO2. And let's say that globally, the cost of the CCUS is between 50 and between 150 euro per ton. So this means that we have quite a number of progress to do technology. We are ready to apply and to reach some goals now. But if we really want to be able to capture more than 5 gigatons per CO2 in 2050, then we'll need to have some progress. And the progress, to answer your questions, there are some progress to be made on capture, because we have some processes that are operational today, but they can, the cost is, we have some progress to make on the cost, to reduce the cost. We have also some progress to make on for the transport. We have to define, to create the infrastructures to transport the CO2, and we have also to make some progress on CO2 storage, because there are a two-level number of storage that are operational today. Did I answer your question, Jean-Charles, or do you want something more specific?
Yes, thank you, Florence. So I don't know if you have still time for some question, Lucia, or because
well,
sure.
We say that we stopped at 7:30, but if people want to stay more, I'm willing to stay. I would just, if I may ask a question myself, is concerning also maybe the cost of CO2. I heard Florence say we need to reduce cost of capture, transport, and storage. And how about increasing maybe the price of CO2 from 50 euros?
Yes, you're right, Lucia. This means that today the CCUS has not been deployed at an industrial scale. So this means that we have quite a number of possibility to reduce the cost. This is some point, but anyway, I personally think that a cost of 50 euro per ton of CO2 is not comparable to the damage that CO2 present in the atmosphere does on the environment. So this means that we have to work once again on the different possibilities to make us achieve carbon neutrality. So this means that there are some research actions that have to be done to reduce the cost, because it is clear that doing something to reduce emissions is of course more expensive than doing nothing. And we have also to have some actions to give a value to low carbon products, and there are quite a number of solutions that can be employed, and one solution is to give really a value. So is it tax? Is it, I don't know, on products that have a low carbon footprint? So all the solutions have to be considered and deployed quite rapidly.
Yeah. If I may add, this is a challenge. You have on one hand the cost of deploying the climate technologies at scale, at industrial scale, and on the other hand the question of the price of carbon. This will be the topics that will be discussed next week in Paris on the carbon price at the carbon pricing conference I was mentioning in my talk.
Wow, so it's, yeah, very interesting. So Jean-Charles, since we co-organized this, maybe this with this announcement by Isabelle, we can close our E after work. What do you think? Do you agree, or you still have some?
I have only one additional comment, if I may. You mentioned, Lucia, in the opening that there is the EAGE Get21 conference in Strasbourg in November, I think.
Yes.
Yes, and you mentioned that the deadline for the call for abstracts was the 1st of June.
Yes.
And I am in the committee, organizing committee, and I have just been told 1 hour ago that the deadline is going to be extended to the 15th of August.
Okay.
I invite all the CCUS community to send the abstracts and attend the conference.
Thank you, Isabelle, for this announcement. So, so Jean-Charles, can we say it?
Yes, I'm pretty sure there are plenty of questions, and we could discuss longer. But okay, I arrived a little bit late during the Isabelle presentation, so I missed the presentation from Florence. But from what I've seen, it was really a lot of great information and message based to all the people. So thanks very much for these very positive presentations. Okay, and the example of Dunkirk as well is very motivating, because we see that we are in the real world for the CCUS, even in France, where okay, we were used not to be maybe not so much in the real world for the CCUS, even if there were some people like you, Isabelle and Florence, pushing from a long time ago these ideas in Europe. So I would say from my side, thank you very much for all the great speaks. And the floor is you, Lucia, if you want to close the meeting.
Well, I want just to thank all the attendees and our speakers, Florence, Isabelle, and Claude. Thank you very much for these interesting presentations. Good evening to everybody.
Thank you, Lucia.
Thank you so much.
Bye.